Today we're going to talk about the difference between radical notation and rational exponents. Radical notation is like this, the nth root of a. And this symbol, we would read it as the nth root of a. N is called the index. It tells us which type of root it is, whether it's a square root or a cube root or a fourth root. And A is called the radicand. The radicand is the number that is underneath the radical. This is compared to A raised to the 1 over n. These two things mean the same thing. A raised to the 1 over n is the same as the nth root of a. So what you might notice is that the bottom part of the fraction is the index of the radical if you were going to translate them from one form to another. So our first step is to rewrite the expression using rational exponents. Rational means fractions, so a fraction exponent. So these are currently written in radical notation. We need to change them into rational exponent notation. So the fifth root of 9 becomes 9 raised to the 1/5. Let's jump over to number 3. What do you think number 3 is? (36) raised to the 1/4. What about number 2? What does number 2 say right now? It says radical 15, but if there's no number there, that's a square root. If we don't see a number in the index, we're talking about a normal square root. Normal square roots, the index is 2. We don't write it because we use square roots so frequently that it's just understood that a square root symbol with no index shown, it's a square root and not a third root or a fourth root. So if you see a radical with no index shown, that means it's a square root. That would be 15 raised to the 1/2. And it's kind of interesting. If you grab a calculator and punch in, like, what's the square root of 16? 4. So if you grab a calculator and punch in 16 raised to the 1/2, it's going to give you the number 4. So here's my calculator. 16 raised to the 1/2 is 4, because an exponent of 1/2 is the same as a square root. Okay, if we write it from radical to rational, now we need to go from rational to radical. So 18 raised to the 1/3. The bottom part of that fraction is going to be the index. So this is going to be the third root. It would help if I could change back to a pen, please. So the third root of 18. Some people like to write the square root symbol and then put the 3 in there. I tend to write the number and then put the check marky thing around it so that that 3 is nicely tucked into the square root. The thing that you do not want to do is write it like this, because that looks like 3 times the square root of 18, which is completely different from the cube root of 18. So make sure that your index is tucked neatly into the checkmarky part of the radical. That's a very technical term, the checkmarky part. 8 to the 1/4 would be the fourth root of 8. Okay, next up, this thing looks a lot more confusing than it is. It's honestly easier just to show you. So on this calculator, I can do the third root from my math button, and on your calculator, you probably have, some of you have a third root button, but usually it's an X root. So if I go into my math button, there's an X root button. The X root, you can tell it what you want that X to be. So what I would do is like the fifth root, so 5, and then I click on that X root of whatever, and then it would calculate it. If it's an odd root, an odd index, if I do -2 to the third, -2 in parentheses, raise it to the third, I end up with -8 because -2 times -2 times -2, that's an odd number of negatives. They don't cancel, so it's -8. So I can do the third root of -8 and get the answer -2. Can I do the square root of -16? No, that's an imaginary number. So this thing, what it's trying to tell you is if it's an odd index, there is one real nth root. If it's the odd root of a positive, your answer is positive. If it's the odd root of a negative, your answer is negative. For example, the cube root of 8 is only 2. The cube root of -8 is only -2. If you have an even index, like the square root or the fourth root, then you are going to have 2 real roots. For example, the fourth root of 16. Anyone know what the fourth root of 16 is? The fourth root of 16, calculator says 2. It is positive or -2. 2 to the fourth is 16. -2 to the fourth is also 16. So odd index, one answer, same as what you started with. Even index, 2 answers. If you have an even root, but it's like the fourth root of 0, the fourth root of 0 is only 0. And if you're trying to do an even index with a negative number, there are 0 real solutions. It's going to be imaginary numbers. The fourth root of -16 is an imaginary number. And we did imaginary numbers with square roots. We're not going to do imaginary numbers with fourth roots and sixth roots because we're just not. Okay, find the nth root of a. We want the fifth root of -32. Okay, fifth root of -32. In your scientific calculator, you would want to type 5. And then the scientific calculator that most of us have, we push second and then this caret button because above that it says x root. And then you type in -32. So on your screen, on your scientific calculator screen, it should look like 5 and then the little x root symbol and then -32. And our answer is -2. If n is 3 and a is 64, they want the third root of 64. So let's find the third root of 64. Try that in your calculator. And then try the fourth root of 16 in your calculator. Okay, so we found 4 and 2. Technically, the fourth root of 16 could be positive or -2. That really only comes into play when we're solving equations, which is what we're going to be doing tomorrow. So if it's an even index and you're solving an equation with radicals, you will have to put a plus minus in there. Okay, now we're going to keep going with this a little bit. We already know that the nth root of a is the same as a to the 1 over n. We're going to add to that a little bit. A raised to the m over n. The n, the bottom of that fraction, is still going to be the index. That whole thing is then going to be raised to the m. So I'm going to write this bigger over here. The n is going to be the index. The m is going to be the exponent. So this becomes the nth root of a raised to the m. The fourth root of a raised to the third. Did I say a? I meant 8. All right, so we've got 8. The little 4 is the bottom of that fraction. The 3 is going to be the top of the fraction. That's the same as 8 raised to the 3/4. Now, you try number 10 on your own. Pause the video, try number 10 on your own. Hopefully you got 45 raised to the 2/3. Now, going backwards, if it's 88 raised to the 2/3, and it looks kind of funny when the fraction is like that, if you need to, you can like off to the side write that the fraction is 2/3. This is the 3rd root of 88. Put parentheses around it, and then raise it to the 2nd. Now, you try number 12. Did you get the 3rd root of 54 raised to the 4th? Okay. Now, normally at this point, I give you guys a perfects chart. And actually, I'm going to show that to you, and I'll put it up on Schoology so you can start using it if you want to. This thing is called a perfects chart. It is a whole bunch of numbers, but basically, it shows you like 6 to the 2nd is 36, 6 to the 3rd is 216, 6 to the 4th is 1,296, 6 to the 7th is 279,936. So you can use this to take a number and raise it to an exponent. You can also use this to take the square root or the 3rd root or whatever. If I want to take the square root of 100, the square root of 100 is 10. The 5th root of 371,293 is 13. So you can use this to go forwards, to raise things, and to go backwards. So on this example, it's asking us to do... It's asking us for the 4th root of 81. So if you look at this chart again, the 4th root, go to the 4ths column, find 81. Do you see 81 in the 4ths column? And now trace that all the way over to the left. What is the 4th root of 81? 3. The 4th root of 81 is 3. So you can do this without a calculator if you have a perfects chart to use. Negatives are a little bit weird. The 3rd root of -8. The 3rd root of +8 is 2. So the 3rd root of -8 is -2. And then we want to raise that to the 5th. How many negatives are you going to have if you raise something to the 5th? Negative, 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 negative. 5 negatives. Is the negative going to cancel out? No. So our answer will be negative. 2 raised to the 5th is 32. So negative 32. When you see examples that have rational exponents, it's honestly better to change it into radicals. So this is the negative is kind of out front. They want you to do the negative last. So really, let's just look at let's look at 49 to the 1/2. This is the square root of 49, and then they want you to put a negative on it. So what is the square root of 49? Do we know that one off the top of our head? 7. Our answer is -7. 3,125 raised to the 2/5. If you first change that into radical form, do what's inside the parentheses first. Start with the 5th root of 3,125 and then square it. So I'm going to bring that chart up again. The 5th root of, what was the number? Was it 3,125? Is 5. And then what they want us to do with it? Square it, 25. So the 5th root of 3,125 was 5. Then we square it, and we get 25 as our answer. Okay, number 17 is a little bit weird because there's a negative. This just means 1 over 64 to the 2/3, which means it's 1 over the 3rd root of 64 squared. Ignore the 1 over, just do this stuff on the bottom. So on your own, do the stuff on the bottom. Okay,